spikes and spines. Although they weren't armored like the placoderms of the Devonian, these were still equipped with some nasty-looking stuff. Although some people think these odd brushes were more for mate selection, mate attraction, than they were for protection, or probably both. By the time we're into the Carboniferous period, there were a lot of sharks, no longer armored fish, but sharks and things called holocephalans that swam around in these gardens of crinoids that populated the mid part of our continent. And they were, in some cases, clearly feeding on crinoids and also brachiopods, because gut contents have been found in some of these, and they show broken pieces of the shells inside. There were bony fishes, too, coming along in the Devonian, and odd spiky things called acanthodians. Again, the spininess is very significant, perhaps, but these were also small-scale predators. And there were fish. We found a wonderful occurrence of these last summer up in New York State, and Glenn has the material down at the Cincinnati Museum now. We were helped by a friend, Bob Carr, to come and get these out. What we found were these whorls of sharp teeth. These were kind of lobefin fish that swam around in the Devonian and later seas. This particular group was Devonian, and they had very formidable-looking saber-like teeth. This is actually based off a specimen from Australia, which has a little armor-plated placoderm inside it that's about a third of its own length. So they could be pretty scary things. And finally, there were lungfish, which today live in freshwater or ephemeral ponds. But in the Devonian, some of them lived out to sea, and they had very weird-looking teeth, which were clearly specialized, as some still have, for crushing hard shells. So they were putting an impact on shelly things too. Direct evidence for predation comes about only rarely, but sometimes we have it. There have been wonderful studies, perhaps you heard about these yesterday, from the Cleveland shale, but this has to be my favorite, if only because it's so whimsical. This is actually based on a small placoderm found associated with a spiny shark from the Cleveland shale, and the shark was bitten in half. In the actual specimen, it's in half. Not so good for the shark, of course. But I call it the poster child of a lose-lose situation, because in this case, that shark had a spine on its fin, and the specimen of the placoderm has the spine jammed up into its brain case. Not a good thing. That fish died at the same time as its prey. So sometimes these arms races don't work. Okay, we also find coprolites that indicate things about fish predation. Spiral coprolites from sharks are known, and some of those show evidence of what was being eaten. Other fish in many cases, but also some conodont animals, those little and also a few invertebrates as well. So we can get to the real poop from these kinds of fossil feces about diets of predators. At least it helps. We can also see other kinds of trace fossils called divots, which are little crescentic-shaped marks. These are drawings from ones in Paleozoic shells. We see them in the modern, too. Little interruptions in the shells. These were survivors. These shells were bitten, and their growth was interrupted, but they survived and lived to regrow. Well, we do find the evidence for such things back into the Paleozoic. Sorry for that picture, but it's from our paper of last year. We documented Devonian clams with distinct, what appear to be bite-made breakages, which were then healed. So we have healed bites or repair scars starting to show up abundantly in the Devonian period. We also see evidence from crinoids and other echinoderms for regeneration. Echinoderms can regrow things very well, called regeneration. And here, the arms were bitten off in part here, but you can see the little regrown part. So we know these are further evidences that let us know that there was predation going on these animals, probably by fish, perhaps some arthropods. In general, these bite marks tend to increase up through the late Paleozoic, but then they tend to, in some cases, drop off, perhaps because the predators got so good that they destroyed the evidence. We don't see them actually leaving behind marks that were regrown. Last and not least, I want to talk a little bit about the effect of all of this on prey. Okay, I've hinted at this throughout, but I want to talk particularly about the arms race that occurred in the middle part of the Paleozoic era, starting in the Devonian, when we see a lot of evidence that the prey was beginning to react to this rise of predators. Going back to the Devonian again, and reminding you that this was a time of great intensification of many vertebrate predators, and some arthropods too. This we call the Middle Paleozoic Predator Revolution, at least in some fashions we've called it that. And again, just a little more detail, but you see that graph, and you see that fish were a very important part of it, getting back to my original theme, what's going on in seas with and without fish. Now we're into a time when there were fish, and they were biting fish. What is the prey response? I'll just show you a few pictures mostly, but there's some quantification that can be done with these things. The first brachiopods, shellfish, that show spines are Devonian. Coincident with that rise. Spines may help them in their nestling in the sediment, but they also are shown to protect from both biting and drilling. Remember the snail drilling type predators. Trilobites show an abrupt increase in spinosity in the Devonian. These from Morocco, showing bizarre things like this Dicronurus, which has these strange curved ram's horn spikes, and this crazy thing called psychopyge. I don't give it my German colleagues' pronunciation. But this is a famous trilobite from Morocco. All of a sudden, many different independent lineages of trilobites sprout odd spines. Now people say, well, it's sexual selection, they're just attracting mates. Okay, but why weren't they doing that very much before, and how come all of a sudden a number of different ones show that? Or if you go to snails themselves, you go back to the Cambrian, the number with spines, of course some of these are small samples, but the number of genera, some of them are pretty good samples, and the number with spines, nil. When you get to the Middle Devonian, it's not still too high, but you can see there's a significant percentage, small but significant percentage of snails that sprout spines. And isn't it interesting that most of those are the very snails that we know were sedentary. They couldn't get out of their own way or out of the way of predators because they were attached permanently to crinoids. And so it's a select group that's showing this spinosity as we go up in the Paleozoic. I showed this before, but just to remind, crinoids were sitting ducks because they were attached. They were up in the water column, although my colleague Dave Meyer may say, and I think it's very right, that crinoids aren't the tastiest thing and may not provide too juicy a meal. Nonetheless, as I told you, there's evidence that some of these sharks did prey upon crinoids. And isn't it interesting that when we come to the Devonian, crinoids, which up to this point had hardly a spine on them, in many different lineages show spikes and spines coming out. It's not 100% by a long shot, but when we look at just at this upper graph, if you would, for a minute, we see that different lineages of different groups of crinoids show a rise of spinosity, but oddly enough, some of them show a drop towards the end of the Paleozoic. Something funny going on there. A lot of them also show thicker plates or more compact calyces at this time, which may also not be just a coincidence. My final example here, before concluding, is this very interesting one, which may show the complexities of interactions that go on. I've already mentioned, my friends, the platycerid snails, these coprophagous, wonderful things that may have also bordered at times into parasitism or predation. Sometimes they didn't just wait for the host to provide them a meal. They went after it by drilling. Okay. So one might say, well, so the crinoids should be defending from these. And perhaps they were. But one kind of defense that surely didn't work, if it were a defense, and I don't think it was a defense from these, was spinosity. Here you can see the most frequently infested host crinoid of the Devonian, Arthroacantha. What does that mean? You know the word arthro means jointed. Acantha means spines. This was the only crinoid that ever evolved jointed spines with a ball and socket joint like an echinoid. Here's another crinoid, you can barely see it down here, called Gilbertocrinus, also with big spikes off the calyx. This one here also shows spikes coming off all the branch points of the arms, making a tough thicket. But a majority of specimens of these, which occur in the Devonian silica shale up in the Toledo region of Ohio, these things sport snails on them more often than not. Very high frequency of infestation. And some of those snails, you can barely see it, but they had spines too.